completing the square is a trick that lets us solve more complicated looking quadratic equations by turning them into simple looking ones. So this one I have at the top is what I would call a more complicated quadratic equation, and completing the square is going to let us take that quadratic equation and turn it into a form like this: x plus k quantity squared equals some value c. From here you could take the square root and solve it just like we did in the last video, but completing the square is the trick that lets us go from the top difficult quadratic equation to the bottom easy quadratic equation. So how do you complete the square? Well, let's try to figure it out, and the way we're going to do it is start with the simple quadratic equation and see if we can make it look like the difficult quadratic equation, and then after that we can figure out how to go the other way. So to make this look more difficult, I'm going to actually multiply out the x plus k squared. When you square a quantity, it's the same as squaring a number. You just multiply it by itself. So to do that, I'm going to distribute this x plus k first to the x and then to the k. So we have x times x plus k times x plus k. And I'll continue multiplying this out. X squared plus kx plus kx plus k squared equals c. You see I'm just multiplying. Now I'm going to collect the like terms. And the final pattern is x squared plus 2kx plus k squared equals c. So now we have a difficult looking quadratic equation that was a direct result from the simple looking quadratic equation, which means that if you see this quadratic equation, then you know that it's directly equivalent to this simple quadratic equation at the top. And notice that this is not just any quadratic equation. There's a certain relationship between the second and third terms that we don't get for free. The second term needs to be 2 times a certain value, and whatever that value is, the third term has to be that value squared. So it's an important condition that we have to be careful we have before we can actually turn x squared plus 2kx plus k squared into x plus k quantity squared. But let me show you this in an example. In this case, it is actually going to meet up with the conditions. So this right here is just the conditions that we just derived, and here's a random quadratic equation that I engineered to match the criteria. So let's go term by term. Do we have a plane x squared? And it is actually important that you have a plane x squared with no coefficient on it. Later in the video you'll see how to handle it when you actually do have a non-1 coefficient on the x squared, but in this case we need the x squared to be by itself. But that's okay for this case. Now we need 2kx. Well, we have a 6x, and remember k can be anything, so that means k is going to be 3. To figure out the value of k, you just half whatever coefficient you have on the middle value. So in this case 6 over 2 gives us 3. Now we want the last term to be k squared. In this case k has to be 3. We get that from the second term. So 3 squared is 9, and indeed we have a plus 9 at the end of this quadratic equation. So that means this meets all of our criteria. And what does it mean if it meets the criteria? Well, it means we can rewrite it as x plus k squared. In this case k is 3, so x plus 3 quantity squared equals 16. And if you want, you can take x plus 3 quantity squared and actually multiply it out like we did above and show that you get the quadratic equation that we started with. But this is actually solvable. That's the key point, is we've taken the difficult looking quadratic equation and turned it into a solvable one. And I'm not going to actually go through the steps to solve this, but in the last video we did several examples very much like this to show you how to do that. Let's do another example. So the x squareds match up. We first check the plane x squared. That's good. Now we need 2kx to match up with negative 5x. So it's okay that in this case k has to be a non-integer. So we want k to be half the middle term. That would be negative 5 halves. So k doesn't have to be an integer. It's going to make things look more messy, but sometimes that's just how it has to be. So in this case k is negative 5 halves. So we want k squared to be the third term. When you have a fraction like this and you're going to square it, you can distribute that squared. So you can square the numerator and square the denominator. You end up in this case with 25 over 4. So that's what we want to be the third term, and indeed that's what we have here. So it meets the criteria, which means we can put it in the form x plus k quantity squared. In this case k is negative 5 halves, so it's x minus 5 halves quantity squared equals 16. Again, now it's in the solvable form, and I'm not going to go through the details of that, but you can see the last video for examples. Now let's look at a case where it doesn't meet the criteria and see what we can do about it. So let's go term by term and see where this fails. The x squareds are fine. We have a plain x squared. 2kx, well, this condition is never really going to fail, right? As long as you have an x term, you can find out what k needs to be. And since k can be anything, you'll always be able to find a value of k that works. So this is not really about seeing if this is possible. It's more about getting a restriction on the value of k so you can look at the third term. So 2k equals -8. That means that k is -4. And so what we want to be the third term is k squared, which would be 16. But we don't have a 16 there. Instead, we have a 3. So it sort of looks like we're out of luck and it's not going to work. But if we think carefully about the basic rule of algebra, that tells us that we can add anything we want to both sides of the equation. As long as we do it to both sides of the equation, the resulting equation is still true. So I'll just add 16. As long as I add it to both sides of the equation, the resulting equation is still true. That's the basic rule of algebra. So now we have x squared minus 8x plus 16. I'm just going to kind of shove the plus 3 to the side and have that -9 plus 16 on the right side. So notice that after we've added this 16 in, we've completed the square. We've made it possible to write this now in the form x minus 4 quantity squared, and then fill in the rest of the numbers as they appear in the equation. So notice how cool it is what we just did. We just took a random quadratic equation with no prerequisites except for the fact that we had a plain x squared, and we just added the exact number that we needed to add to make this form possible. And so that's what completing the square is all about. It's about figuring out what you need to add to make completing the square possible and to get it in the solvable form. Because you notice this is solvable. You can do the arithmetic, take the square root, and solve that. Let's do another example. This one has absolutely no prerequisites. In fact, we have a 2 coefficient on the x squared instead of a 1. So what do we do about that? Well, the trick is you divide both sides by 2. Or you could think about it as multiplying both sides by 1/2. And when we do that, we know that's fair because by the basic rule of algebra, we're doing it to both sides. It's not going to change the truth of the equation. But this is going to cancel with that 2 in front of the x squared. And it's also going to change the other terms in the equation. But that's okay. Now we can complete the square just like we did in the above example. So we look at what does k have to be? K has to be half the middle term. So that's going to be -3/2 in this case. K squared is 9/4, so we need to add 9/4 to both sides. You see, it's not uncommon for you to have kind of messy fractions show up when you're completing the square, but it's just part of the game. So x squared minus 3x plus 9/4, that's what we've engineered to have, because now this meets the criteria that we had above, and we can put this in the form x minus 3/2, that would be x plus k quantity squared, plus 5 equals 1 plus 9/4. And you can solve that out using a calculator if you want decimal values. Before we finish the video, I'm going to do one example where we don't even have an equation. You're just given this quadratic expression and told to complete the square. And this is actually done sometimes. If it's in the middle of an equation in a certain part and you don't want to affect the rest of the equation, you can complete the square on just this expression alone. So the first thing we have to do is get rid of this 3 in front of the x squared. So what I'm going to do is factor it out. We can't just divide it by 3 because we don't have another side to make that fair. So instead I'll factor it out like this, and you can see if I distributed this 3 back in, then it would, this should be 5/3 and this should be 3. If we distributed this 3 back in, then we would get the original equation. So you factor that 3 out, and now we complete the square inside the parentheses. So our k is going to be 5/3 over 2, which is 5/6. Again, it's not always pretty. So we need to add 5/6 squared. So that's going to be 25/36. And we don't have another side to add that onto, so instead I'm just going to write minus 25/36. Isn't that cute? So we just add it and then we subtract it. We know that's not going to make a difference. Then we have that plus 3 on the end. So here is our expression that completes the square. So we have 3 times k is 5/6, x plus 5/6 squared. And then we also have minus 3 times 25/36 plus 3. So I'm out of time, but that's how you complete the square. Half the middle term and then add that number squared to both sides, and you can complete the square. Thanks for watching, and I'll see you next time.